Hi guys, in this video we're picking up where we left off with section 2.4. Our goal of today is to graph a line using its x and y intercepts. So to begin, let's just talk about what x and y intercepts are. We've already talked a little bit about what y intercepts are. X intercepts, put most simply, are the points, so the x intercepts of a line are the points I guess I should just say points, it could be plural, the points of a line that intersect the x-axis. And I could say intercept as well. They're pretty much the same idea. So x-intercepts are the points of a line that intersect the x-axis. So just with a picture, this right here would be the x-intercept right here. And then for that x-intercept, notice the y value would be, the y-coordinate would be 0, and the x-coordinate is some value. I'll just say x comma 0. Now we've already talked a little bit about y-intercepts in previous videos, and we talked about the slope-intercept form of a line. The y-intercepts kind of have the same logic. It's the points of a line that intersect the y-axis. So with the picture, the y, like in the same picture up here, the y-intercept is right there. So probably should have done this a little bit better. But anyway, it's this point right here, and it would have an x-coordinate of 0 and a y-coordinate of whatever this height is here. So now that we've introduced x and y intercepts, x-intercepts are just where a function crosses the x-axis, and the y-intercepts are the points where a function crosses the y-axis. So now what we'll do is we'll go over the process of using x and y intercepts to graph a line with an example. So let's do that on the other side. So on the other side, let's come up with the equation of a line. How about this? How about 2x plus y, or how about 2x plus 3y is 12. This is the equation of a line. It's in the form ax plus by equals c. This is sometimes called the standard form of a line. Okay, now let's go over the process. So first, to find the x-intercept, to find out where this line, whatever it looks like, where it crosses the x-axis, what we want to do is we want to let y equal 0. So x-intercepts, let y equal 0, solve for x. So in that in this equation, if we let y equal 0, we get 2x plus 3 times 0 is 12, or in other words, 2x equals 12. And then solving for x by dividing by 2 gives us x equals 6. So we have an x-intercept of 6, or really the proper way to say it is that we have an x-intercept of 6 comma 0. So that is where the line right here, it crosses the x-axis. So I'm going to mark off that point. 1, 2, 3, 4, 5, 6. Right here. I'm marking off that point right there. Now we're going to do the same, we're going to do a similar process to give us the y-intercept. So for the y-intercept, we let x equal 0, solve for y. And that's because every point on the y-axis has an x value of 0, just like with the x-intercept, every value on the x-axis has a y value of 0. So for the y-intercept, we let x equal 0, and we solve for y. So letting x be 0, we would have 2 times 0 plus 3 times y equals 12. Or in other words, we get that 3y is 12, and then after dividing both sides of this equation by 3, we get that y is 4. So our y-intercept is 4, our b value in y equals mx plus b is 4, but the way that we want to think about it again is as a point. So we'll want to think about this as 0, 4, and we'll plot that point as well, and we'll mark it off. 1, 2, 3, 4, 0, 4. Now what I'm going to do, whenever you have 2 points of a line, that's all you need to graph the line, because you can just use a straight edge like so to graph it. So I'm gonna be going over what I've written up there. That's okay. We'll just be a little bit sloppy here. Cool. So there's my line. It's not the prettiest, but it's close enough, right? We use the X-Intercept and the y-intercept. We found them through this process on the left here, and then we just connect those 2 points with a straight line, and then we're done. So this video concludes, or we conclude this video by just talking about, sorry about that. We conclude this video by just saying that you can plot a line using this way, or the way that we covered in the last video using the slope-intercept form. But just note that the advantage of this way is that you don't need to get it in slope-intercept form. If you're given something in standard form, you can just solve for the intercepts and then connect the points. You don't have to get it into slope-intercept form. So yeah, this is just another way to graph lines. In the next video, we're going to cover some more topics from 2.4. We'll probably finish up the section. So I hope this video was helpful, and we'll see you in the next one, guys. Have a good one.